All right, we're gonna have another session on React development. So let's just jump into the documentation and learn React concepts one by one. So we're gonna understand the components, which are the main foundation about which we build UIs, and well, components are the building blocks of UI, and every component returns a HTML only, right? But in under the hood, we are using something called JSX, which is JavaScript XML. This is basically a syntax extension of JavaScript and XML that helps you write HTML markup with React in a functional manner. So the React components are just functions that return such sort of JSX markup. There are some rules around JSX and some conditions that you need to follow to be able to write uh, correct components. Managing, you also have to manage some state and props, right? So we'll get into each of those, but think low level. Think in terms of the smallest building block, and then compose components together and build your components one by one and share data across them. And sooner or later, from components you grow into larger widgets and then pages and then full applications that have routing and everything built in. So the React ecosystem is very large, but you start with a very simple building block and then you combine everything together, stitch them, and basically this is how React is working under the hood. So React is very smart. So we'll get into the ideas of React. So this is all basic. I think you can go through this. So you have to basically organize components together, and there are some rules around it that you should define one file per component, and then you should mix and match components together and compose them together. And you have a hierarchy of parent to child, and data flows from parent to child, and children can move the state back up, communicate to the parent that this state has to be changed on this action or something like that, right? So let's just quickly go through. So once you create a component with having some isolated functionality in itself, it takes in some properties of data and then it decides what to do with that data and how to render something on the screen. Uh, so that functionality is can be reused again and again across multiple pages or or within the same page in different sections. So you can reuse all those parts, right? So uh, there is a simple uh, mechanism called splitting components and exporting and importing components. So if you want to basically take a component and return it, right? So uh, you have bunch of components and you can either export and import multiple components from the same file, and or you can mix and match default exports and named exports. So default export is something that you will import as the usual name of the file, and named exports are one which take uh, for which you have to specify the name, and that name basically signifies what function or React component you are exporting out. So you can mix and match those, but one file will have only one default export, that is for sure. So yes, this is the difference between them. and you can have a bunch of named exports together, but you will only have one default export. Now let's come into JSX. So JSX is something that helps you write components, and JSX is simpler to work with once you know HTML enough. There's only few rules that you need to follow. Uh, so earlier the problem was that HTML files would bloat a lot, and then they would also ask for external CSS. If you have used inline or internal CSS, then that's also okay, but HTML files would take a lot of content, and there would be a lot of logic that you would be writing in JavaScript to make the websites interactive, right? If you're thinking large scale website like an e-commerce application or a video sharing application, or any sort of tool that has a lot of backend logic and maybe API calls in it. So you would have to manage a lot of stuff in that. And state management will get very painful as the application grows. Even if you use some library like jQuery, it will only make the syntax a bit more easier to work with in comparison to vanilla JavaScript, but it still would have a lot of logic in place, and you would have to maybe build your own framework, and that's why the need of libraries like React came up, so as to make the development process a bit easier. And but it has its own rules in the ecosystem. So uh, in React, React has done one thing good, that they say that whatever logic I want to use to render any application, any part of the application, and whatever is the my markup that I need to take, those should be in the same component. So what that tells is that if there is an there is suppose this is a simple example that you have a search, you have a header and it has a nav bar menu and a search. Okay, so the nav bar menu should toggle its position to open or close based on whether you are clicking on it, and then should have some animation of sliding in and out, right? So that kind of logic to slide out the or slide in the menu, and then to be able to decide what happens on the how does it happen on the click, uh, this sort of logic and the markup for that element, sidebar element, could be an aside tag or could be a nav tag. All of those can live in the React rendering logic and the markup together in the same component, right? So that's just an example how. So the React documentation talks about the same thing, that there is a button and there is a sidebar. So if they're isolated from each other, so you can manage their state management logic inside them locally, rather than uh, mixing up and syncing the logic across the application and then mixing up the logic, which is very difficult to manage later on. So it brings isolation and brings a separation of concerns, right? So so there's a to-do list component, right? This has a header tag and the image tag and um the unordered list, right? So this is how it is done. Now, if you want to return uh, if you want to return various elements from one component, then you can use a single parent tag. Uh, so the J in JSX, You can either add another div, but then that will increase your DOM node size, DOM nodes, and you should have don't have a large DOM node size, so you can use a fragment instead. The fragment is basically an empty tag that lets you group things without any uh, element in the HTML DOM tree. So another rule is that all of the tags should be closed. So either it could be self-closing or it could be wrapped tags, right? For example, this unordered list is a wrapped one and this image is a self-closing with its source, alt, and colors. So whatever attributes you use, some of the attributes would be entirely lowercase and some of them could have camel casing. For example, say you have class, which is a reserved keyword. So for that, we use class name. And then, for example, there is stroke width, then you can use camel case version of that, right? So the better idea is that you write HTML first, and then you basically convert that HTML into uh, JSX. So the HTML becomes JSX, and okay. So after that, say you have this HTML, it is not valid JSX. So what you can do is you can use an online converter and it will convert the HTML into JSX and then you can use that. So that is a very good hack that you can use if you're beginning in React. Otherwise, if you are already writing JSX, you would have enough practice to write JSX directly and not work with HTML at all. So yes, basically, uh, the cool thing about JSX is that whatever variables you are working with, you can also inject that into your markup. For example, if you have a heading and it changes based on some identifier, right? Then you can use that identifier to place that for that title or that heading, or maybe a paragraph is there and there is something that changes on every say click of a button, or there is something that is uh, dynamic in nature, so you can inject that data into or maybe you can use a JavaScript logic and inject that dynamic property into the markup. And this is how you can work with most of the content that you display on your website to make it not static but dynamic. So that makes a good impression that your site is a really dynamic web application and gives a good uh, sort of gives a good understanding to the user. So anyways, uh, so if you want to dynamically specify a source or alt text, you could use a value from JavaScript by pasting uh, commas with curly braces. So you have a avatar and you have a description. So you can take the image and You can make the avatar and description. So uh, class name avatar, and then there is avatar. These two, uh, and this is basically a hard-coded string here, class name avatar. An src avatar means that this avatar can be a variable. So if this component accepts avatar as a parameter and description also as a parameter, then these two can make your component itself dynamic. So we will understand about props in the coming uh, sections, and then the whole idea is that we can inject a variable into our markup, right? So an expression or a variable can be a part of our markup, right? Next is that for the style, you have to use double curly braces. One is, so it's not, so basically the double curly braces, it's basically just an object inside the attribute, right? The JSX attribute is just an object. So this will basically give you uh, give you give you an idea to work with an object if you are making dynamic content, right? So you can try some challenges after understanding this. Next is props. So uh, so props basically helps pass data from one component to another component, but there are few issues with props also. We'll get into that, but I mean, few things you need to note down, not issues, but few things that you can maybe overuse and then get into some re-rendering issues. So the performance can take a sabbatical. So the first idea is that uh, so you basically use an object as a parameter to the function. React functional component. React component starts with a capital letter, and then this is a functional component that you are writing. And then this, you can give it a person and size. Okay. So so after that, you just do that one thing, that you basically give it some data and then configure your markup around it, and then you can use all that data to render dynamic components. So see, first avatar, you are reusing the same component with different props. You call these size, person, these these things as props, and the prop values are different in these. So this will render different sizes of avatars, which is very cool because then you have dynamic UIs possible because of this. So this is basically, so there's a cool thing now. This is something that you can adjust, and then this sort of data that you have uh, would uh, would be dynamic in nature, and you can work with dynamic sort of data structures, and then develop components which act act or behave differently as per the data that they are getting, right? So this is the whole idea. Rest is just syntax, you can get into it. So you can either directly destructure the prop and then give a default value if you want to, or you can directly call it props and then assign variables to that prop values, right? So that is something that you have a choice as a developer to do, right? Sometimes what happens is that there's nothing telling you to not do it or to do it. There's no compulsion around it, but your component might have a prop and you might not need any values out of that prop in that component. You might just need to pass it down to your children component, and that is how you can spread out all the props. Okay, but something is wrong. That first of all, the thing is that you are spreading out the component props, which means that you are sort of creating a clone object out of it. So which is not efficient thing to do, because it will first create a clone and then map out every prop name to its prop value, right? This is one thing. And then uh, you will just write components like that. So the next thing is that you have children components. So basically, suppose you develop a component, right? And then it has, you want to describe the uh, nesting nested children of those components. So one component might have one component might be a container component, a present container component, and the next would be the presentational component. So sometimes you might be rendering one children inside it, or sometimes you might be rendering some two, three, or maybe k children inside it. So k can be a variable, right? So you can sort of write a logic to render children as you want, and whatever in whatever capacity you want to, right? So suppose you're developing a card and then opening that card does some uh, sort of logic. So that is something. Next is conditional rendering. So Okay, conditional rendering you can do with three major ways. So one is you can use if statements to render something based on a condition, or you can use double AND operator, or you can use the ternary operator. So what it does is that this is the JSX that I want to render. So it could be the first condition, or it could be the second condition. So this is how you understand that. So uh, say I have a packing list. So I have a section, and then inside that I have a heading, and then I have some items that I'm rendering, and I'm saying that okay, one of the item is packed, the one of them is not, and they have a name, right? So it looks like this. Now if I want to render that, okay, if it is packed, that I want to render a check mark, so I can use the if syntax, or I can also return null in that case, right? So that element won't be rendered, right? So logic is in my hand. I decide what to do with that logic, right? But that condition totally determines what happens on the front end, right? So in this example component, I am taking I'm taking an idea that this a lot of markup is duplicated. So in this condition or in that condition, I would do return only one thing, but a lot of that markup is just duplicated. So it does not do anything great, right? So this duplicate makes your code harder to maintain, and there is a principle called do not repeat yourself. So you are doing the same thing in two places. You're defining an list item, you're giving the same class names, you're using the same name, but the only difference is this check mark. So you can basically write a ternary operator that every time I'm returning an li, but when it's packed, I'm returning a name along with a check mark. Otherwise, I'm just returning name. And then this is also good enough, but there is even a better way that uh, you can uh, kind of use the logical AND operator and keep everything common, and just for the check mark use the is packed and condition, right? So in that case it will render it. So there is one pitfall with the and expression. The and expression is that if the condition is false, then it will not render anything in its place. But if it is a number, then that number value would be returned, right? So you will have to uh, actually write a boolean to be able to uh, make it work conditionally correct. Okay, so uh, right. So what happens is that okay, now the next thing is the next good thing about React is that you can render lists in React, but for that you'll have to understand a bit about arrays and a bit about array methods. So array, let's talk about array. So array is something that uh, stores a collection, right? And collection of things. It could be numbers, it could be objects, it could be booleans, it could be anything that you want to use, right? And it could be uh, any data point in sort of numbers or strings or combination of those or objects of those, right? So you can use some of the array methods to transform your data into array of components, right? So suppose I have these statements that I want to render inside an ordered list. So what I can do is I can create an array of this data, and then I can map it and then convert that data from, just do a transformation function to convert that data from one uh, one thing to another, right, to the list items. So suppose that uh, there's a chemist. Okay, so you can use filter method, right? And then there would be an array of items, and then it will take a test. It will return true or false. So you want only the items where the profession is chemist, right? So you can map over the chemists then, right? And then you can say that, okay, I want to render some dynamic information based on, I want to render some markup containing some dynamic information. So the source gets from the person object, we get the alt from the person name, and then we render person name in the bold tag, and then we render a headline about them inside a paragraph. So then these list items appear on the UI something like this, that this is a person's photo. One second. This is a person's photo, and this is the card that renders their information about what they are known for as a chemist. Okay, so you can use that mapping logic to render an item. But there's one thing, you also need to supply keys. So keys basically tell you that which is the array item each component has. So if your array items can move due to sorting, get inserted or get deleted, so that key helps React infer what exactly has happened, and it makes the correct updates to the DOM tree. So instead of generating keys on the fly, there should be in your data, right? Criolla Catherine Johnson is a mathematician known for space flight calculations. This is a chemist known for discovery of Arctic ozone hole. This is a physicist known for electromagnetism theory, chemist known for pioneering cortisone drugs, and then astrophysicist known for white dwarf star mass calculations. So we can render this data based on the object, right? So we have a people's data, ID is used for a key, then we have a name, then profession, and accomplishment, and the image ID. So based on that, what we do is we convert the image ID into a URL from the person object, and then we render that image along with the person's paragraph, and then we wrap that inside a UL. Then this becomes our list component, and this is how we render it. So basically, suppose one item has several DOM nodes, right? So you can use a fragment tag rather than a div. Now, how do you when you render something? Uh, you can you can use data from a database. So the database might give you a primary key you can use, which is unique, and that you can use to provide data to the component. Other could be the locally generated data. So if your data is generated locally by the application itself, then you can use random UUID or a package like UUID to create items. So one thing is that keys must be unique among siblings, but you can use the same keys for JSX node in different arrays. Also, the keys should not change, otherwise it defeats their purpose. So do not generate them while rendering. Okay, so now let's dive deeper into why do we need keys, right? Suppose uh, suppose that you have one element in the list, right? But then you do something with that element and you delete it or you edit it or you move it around, drag and drop it. So what will happen? The item order or the list item ordering and the count and the IDs of those things would change, right? Okay, so these file names and the JSX keys, they have a similar purpose. So basically, let React with the help of key, the React would know what is the item order throughout its lifetime, right? So we can use an item index, and if we don't specify a key, then React will do the same. But uh, if we insert or delete or something happens to shuffle the array, then obviously your item order will change, and then there would be confusing bugs. Similarly, we cannot do something like mat.random also, because all your components and DOM uh, will be recreated every time. So you can use a stable ID based on that data. Note that your components won't receive key as a prop, it's only used as a hint by React itself. So if your component needs an ID, you'll have to pass it as a separate prop. So the next thing is that some JavaScript functions are pure. Okay, so pure functions, they do a calculation and then nothing more. So if you write only your components as pure functions, there would be a lot of less bugs, right? And there would be less unpredictable behavior as the code base grows. But there should be few rules. So in the world of functional programming, what is a pure function? If you give it some input, it returns the same result every time. Okay, with the same input, the same output will come, right? So it does not change any objects or variables uh, that was not inside its own scope. Okay, so if it is getting some external data, it is not mutating that, right? So it's like a function only, right? So if you're doubling a number, you can just double a number. It's a pure function, right? So React assumes that every component you write is a pure function. So if you give it the same input, right, it will return the same JavaScript markup. Okay, so Then there is spice chai recipe. Wow. Wow. So obviously this component takes a number of how many drinkers are there. So based on that, you generate dynamic component that has uh how much spoons of tea you should have, and how much spoons of spice you should have, how much cups of water you should boil, and how much cups of milk you should boil, and sugar to add for taste, right? So for two people it should be this, and for a gathering it should be 4 cups of water. So it's just a math formula, right? So so what is impure? Impure is side effects which you don't want as a consequence. So you should not have side effects at all, right? So uh, what is bad? So basically there is a guest, and then guest becomes greater than guest plus one, and then take up for guest is guest, right? So if you're changing an existing variable, then that basically becomes a problem, right? So that's the issue. So this component is reading and writing a guest variable declared outside of it. This means that calling this component multiple times will produce different JSX, and if other components read guest, they will produce different JSX too, depending on when they were rendered. And going back to our formula, y equal to 2x. Now, even if x equal to 2, we cannot trust that y equal to 4. So our test would fail, right? Because it has incremented the guest variable before once, right? So we made it in the tset component, we called it with 3, and then that variable becomes uh, so React in strict mode renders it 2 times, so it becomes 2 first, and then 4, and then 6, right? Which should not happen. Every time it should have been 2, right? Now if we need to have that behavior, so we can use guest as a prop. Based on that, our guest variable will determine how many cups should be there. Uh, sorry, teacup should be for whom, which guest ID, right? So this makes the component cleaner. So if you use strict mode, okay, so there are 3 kinds of input, right? That you can read. One is props, next is state, next is context. Okay, so context redux is also right, like a context only. So you should always, so context is global, state can be local, or it can be living in a parent component passed down to the child component, and similar for props, right? So when you change something based on data, we should set state instead of writing to a variable. So we cannot change the existing variables or objects while your component is rendering. For this, React has a strict mode, right? So it calls the function twice during development. And this basically helps identify the components that do not follow these rules. So basically, in our case, the guest number 2, guest number 4, and guest number 6 we're getting instead of 1, 2, and 3. That is where component broke, because it was not pure. Okay, so this is the idea. Now, so this is called a mutation, that you are existing, you are basically mutating a pre-existing variable while rendering. Okay, so So now in this component, we can generate a loop and we can push items to the loop, and then we can, so this is perfectly fine because this is not an external variable. Like we are creating an array and we're pushing elements to an array and then we're rendering that, right? So this does not break any rule of React, but the strict mode breaks a rule of React. So if the cup variable or the empty array was created outside the tree gathering function, it would be a huge problem because you would be changing an existing object by pushing items into that array. But since we have done it in the local mutation, this is fine. So it's like your component's little variable. Now, uh, although you want pure functions, right? Sometimes you can make side effects to change the data. For example, there's some animation happening. Okay. Sometimes you update the screen, change the data due to something, right? Some user action happens, right? So swipe or uh, basically swipe changes the carousel into the view, brings the carousel into the view, or you can render a element that opens another modal inside it. Okay, these are side effects. So React, the side effects usually belong inside event handlers. So event handlers are functions based on which you perform some action. For example, when you click a button, even though event handlers are defined inside your component, they don't run during rendering. So event handlers don't need to be pure. So if you do not have the right event handler for your side effect, you can attach it to your return JSX with a use effect call in your component. So based on this, React has to execute it later when side effects are allowed. However, this approach should be your last resort. So you can express your logic with rendering along, and you will be surprised how far this can take you. So making pure functions requires some discipline, but there are some idea with why you should do it. So first is that your components can run on the server. Okay. So since they have the same output for the same input, you can use one component and multiple user requests can be served. Okay. Then uh, then you can improve performance by skipping rendering components whose inputs have not changed. Pure functions will always return the same results, so they are safe to cache. If some data changes in the middle of rendering a deep component tree, React can restart rendering without uh, wasting time to finish the outdated render. So with the help of purity, React knows that it is not gonna calculate it again, so it can calculate with the new data and render it again. Okay, so now think of so always you think your HTML is a tree, right? It has a tag, parent tag, body tag in the main, and then wrapper devs, and then maybe sections or main element or a side or a nav. All of these sections, header, footer, all of these semantic elements, all of these basically make up your DOM tree inside your application, right? So React also follows the same paradigm. It basically thinks of components. So what happens is that all of the components nest each other. one component can have a child component, can have a multiple children component, and they can share data across each other, right? So this is how you should model your UI. Your UI should be a relationship between different items. So this modeling of relationship happens inside a tree. This is very good concept. So suppose you have one parent component, right? And it takes any child inside it. So you can use it in multiple parts of your application or different pages of your application to render dynamic content, because you have some bunch of components that you do not want that you want. In one case you want this component parent component to hold a different child, and in another page you want this parent component to hold a different child. So this basically makes your components reusable and stitchable together, and you can manage data across them, right? So your component design is very advanced here, but it basically makes your uh, rendering process very good, right? So okay, so there is one more idea which is very nice about React components. This is platform agnostic. So currently we're talking about web elements, which are HTML elements. But if you want to use mobile platform, so React Native is useful there, and it basically shows you the UI view or the framework element for desktop elements. So the React render trees basically control how the based on the platform that your app renders to. Okay. Also, we can use variables to determine which child component to render inside a parent component, which is the idea behind conditional rendering, right? So if you think about this, this is the module dependency tree, right? So the first thing is app.js imports this, imports fancy text right? And inspiration generator imports fancy text color and inspirations.js, right? This is the module entry point. Entry point is app.js, right? Now the render tree is very large here. I mean, it's not that large, but it's a small. It's large enough. So as your app grows, the bundle size also increase, and that's why client applications cannot download and run a large bundle. So your UI will take time to uh, draw. So basically, although you want to have a lot of features in your UI, uh, knowing your dependency tree will help with debugging these issues. Okay. In the next session, we will talk about interactivity and understand the phases of how can you understand events programming. For that, you should tune in for the next session.